Right. Welcome back. I'll start your new lesson, that is chemistry topic, chemical equations. Right? Chemical equations. So in your sixth class, seventh class, and also eighth class, you learned about some changes. Right? In sixth class, you have the topic changes around us. Changes around us. Then in your ninth class, last lesson, 17th lesson, I think, it may be changes around us only. Right? In that, 7th class, 17th lesson, right? 6th class, lesson number 10. Okay, just observe them, right? What the topics are given in them, right? Here, that lessons will give you idea about understanding the changes actually. So what you can call it as change actually, generally, in your daily life, what you can call it as change, which is called as change, according to you. If something looks differently, comparing with the previous, something looks differently or different, right? Comparing with the previous. Okay, here, many changes we observe, many changes we can observe. Yes, sir, no. Many changes we can observe here, right? Here, daily we come across different changes from morning to evening, day-to-day life, or in your activities, or within you, right? So that we will notice, and especially we can classify them into different categories. Suppose in your sixth class, you learned temporary changes, permanent changes, slow changes, fast changes, man-made changes, natural changes, right? Like this you classify. Okay, like this you classify. So in them, especially in a seventh class, you classified that changes into one more category, right? They are called as physical changes and chemical changes, right? So how do we classify them into physical changes and chemical changes? What is actually physical meaning? What is meant by physical? Can anybody? Just I asked a general meaning. What you can call physical? What you are able to see, appearance, right? It is what externally appearing, right? Like we are feeling or we are experiencing shape, size, color, right? These are called as physical appearance, right? It's a state, right? These are what? These are what? These are physically appearance. So physical characteristics or properties, right? So here, if there is a change in these characteristics, that change we may call it as physical change. Other than this, if you are observing, right, invisible things, like it's a smell, taste, we cannot see them. We can feel them, right? We can feel them. So that or comes under another category called chemical changes. Directly, you are unable to see them, right? With the physical changes, you may observe that characteristic properties, right? Like a smell, like it's a taste, right? That maybe comes under another category, chemical changes. Are you following me? Am I clear? Any confusion? Screen is visible. My screen is visible. So here in this lesson, the topics what we are learning in this chapter especially. So especially we will learn about the changes, right? And a classification of changes. In this classification, we have a particular change, chemical change. So what happens if a chemical change is observed, right? Then here that can be classified into a reaction. If the reaction takes place, you are able to write the equation for this and the characteristics also for the reactions. Then by that characteristics, you are able to what make them easy to express, right? That we can call it as equation. Then in this equation also we have different types, right? They are called as here types of chemical reactions or types of chemical equations. The types of chemical equations will satisfy anything or not. So here always we are following one law of conservation of mass in chemical reactions, right? It can be applicable, it can be proved, right? Mass neither created nor produced. So in the chemical reactions, only the combination changes, but there are no new elements produced, right? Then if that equations are satisfying the law of conservation of mass, it is said to be a balanced equation. If not satisfied, they are going to be balanced. So we can balance that equation to satisfy the law of conservation of mass. Then, are there any limitations of chemical equations? Right? Yes, there. Then we can make them more informative. Why? Overcome that limitations. Right? Making that chemical equation size more informative. After that, we have one more topic that is interpreting a balanced chemical equations. Right? Interpreting a balanced chemical equations. By that, we can solve the numericals. Right? So these are the topics that are covered in your second lesson. Have you seen them? Did you find these topics in your textbook? Sricharan, Vikrant, Rohit, Abhinay. Have you seen them? Yes. So these are the topics we are learning in this topics. Right? Let us move into the topics. First of all, in the introduction part, you have few examples. Right? Before that, I'll just remind you your basic knowledge, what we require. So here, we need to identify the change. Right? When do you feel something has to change or something changed? Right? By the physical observation. Right? Physical observation. Right? Suppose you placed something back at somewhere in the morning. Right? Then, if you locate that at somewhere, did you feel any difference or not? That position changed by someone else. You came in the evening and observed that same bag, right? What do you feel here? That position is changed. Or something is broken. You can observe. It's a shape changed, right? So like that we can feel, right? So changes are what here? Something is replaced by maybe same kind or different kind, right? So here replacing with something else or especially something of same kind, right? So that we can call it as change here. Okay, here simply the changes are classified here into two categories, right? What they are here, maybe they are in its appearance changed, or its internal characteristics, right? Like what generally we may feel its smell, taste is different. For example, food is there. Today morning you prepared, tomorrow morning you are going to eat. Directly you are eating? No. We are smelling that food. We are observing the physical appearance, right? Is there any water formed on the food surface, right? Or giving unpleasant smell, like that we are observing. So that change is chemical change, right? So here we have two categories here in the classification. One is here physical change and the other is here chemical change, right? Two types of changes we are discussing here, physical change and the other is chemical change. Here, what are the physical changes? Which are said to be physical changes? Here, if only its appearance is changed, like a shape, color, size, right? So that physical characteristics only changes. A substance is changed in its physical appearance, it is said to be physical change. Can anybody give me example for the physical change? No other characteristic properties change. They can remain same. Anybody
Sir,
give me?
melting of ice.
Very good. We can give example, melting of ice into water. When ice melts, what happens? Simply look at here. Ice cube melting. What it can form? It can form the water only. It can form water. Its physical appearance changed. Its physical appearance is changed. Solid converted into liquid. But there are no changes in its characteristic properties. We can write the formula composition of the ice or maybe composition of water as same, right? We cannot smell differently. We cannot find any variation in the taste like that. Okay, so this is example for the physical change. One more I will give you here, tearing of paper. Only it's a shape, size, like that only it changes. But are there any change in the composition? Teared paper, just you can see the pieces. Nothing is changed. Size, it's a shape maybe changes by tearing of this. So these are example for physical changes. Can anybody classify these as temporary changes or permanent changes? Physical changes are temporary or permanent changes? Can anybody?
Temporary change.
Are you sure?
Yes, sir.
Suppose break, if I break a rock into pieces, is it a temporary change or permanent change?
Sir, permanent change.
So, are you able to decide, is it a compulsory temporary, compulsory permanent? No, it depends on the situation, right? So here it may be temporary change or maybe the permanent change, right? Temporary change or permanent change. Clear? Next, I'm going for chemical change, right? What are chemical changes actually? Here, it forms you completely a new different substance. Comparing with the original substance, its characteristic properties completely changes. So unlike to the original, what properties? Properties completely unlike to original. Suppose if you prepare curd, so milk and curd. Curd is product of milk only. Here, characteristic properties of milk and curd completely different. It's a smell, it's a appearance, it's a taste, whatever it may be. Everything is different. So that is said to be permanent change and chemical change. Are you following? Are you following me? Hello? Yes. So we have two types of changes, physical changes, chemical changes. In the chemical changes, we will notice a new substance will be produced at the end of process. So simply it is a process, right? It is a process producing new substances with different characteristic properties, unlike to original substance, right? So what are the examples we can give for this Here, textual examples are there. That only I am using here, right? Textual examples only I am using here. What they are here? Simply digestion of food, right? What is digestion of food? So here we are swallowing the food. After that, what happened? It is processed, right? What? Producing the energy. Respiration process is going on. Burning of carbohydrates in the presence of oxygen. So in this, simply we are swallowing the food. It moves into your intestine and digested. Then the remains we are releasing as excretes, right? So here simply that process is going on. Okay, so completely you will get unlike, right, different substances. Is my screen visible? My screen is visible? Yes, right? So here, simply this is about digestion. Here, is it a chemical change or physical change? Is it a chemical change or physical change? Why it is said to be a
Chemical change.
chemical change? Why it is said to be a chemical change? What we
Because
are,
there are some chemicals involved in digestion.
right, in the digestion process, some enzymes involved and some gases combined, right? Here, oxygen is there. Then gastric juice combined, saliva mixes, right, with the food. All them together producing energy and the wastages, right? In this, what are the wastages? Carbon dioxide releasing out, excretes released, right? So many are there. So this is giving you many products, new substances, unlike to the food particles, right? So that's why it is said to be chemical change. Then one more example is giving you here, burning of crackers. So here, if you burn crackers, what is left after a burning of crackers? Ash. While burning, what you can observe? Gases released, right? So, unlike properties or same properties for the products, new substances formed, gas released, fumes, then ash left. So here, unlike properties to the original substance. So burning of crackers is example for chemical change. Process of respiration. So what is actually respiration? Only breathing in, breathing out is called respiration. Can anybody give me meaning for respiration? Respiration is what? Simply, it is a process. What process? Burning of carbohydrates in the presence of oxygen. So what you are breathing in, oxygen, helps that process, burning the food particles, carbohydrates, and mixing with the blood, right? So this process is called a respiration. So here you are breathing in oxygen, releasing out carbon dioxide. So new substance to me. And in this process, you are producing the energy, releasing the wastages. So respiration is also example for chemical change. Then lime added to the water. So here, adding lime to the water, what happens in this? Combines water and calcium oxide. They will give you a new product. And if you touch that contents, right, in the beaker, right, then you will feel hot. If you check the nature of the substance, water nature is different, calcium hydroxide nature is different. Okay, so this is also given as example for chemical change. Then ripening of banana, is it temporary change or permanent change? Permanent change. Here what happens? It is oxidizes, right? So its characteristic properties changes and decomposes. If you left in the oxidation process, it decomposes and mixes with the soil. So this is also we can give example for chemical change. Then finally, one more example is given, rusting of iron. So if you left new iron nails in the atmosphere or exposed to the water and air, what happens? They turns like this. New iron nails turns like this. This is what oxidation process. This is what oxidation process, combining of these metal particles with the oxygen in the presence of water. So they combined. So this is what we can call it as. Here, give me a response. Textual examples, right? They are clear. Okay. Then next here, we know about the chemical changes, physical changes. Chemical changes are permanent changes, and physical changes are temporary changes, maybe permanent changes, right? Then here we have activities in our textbook. What their activity one is adding the quicklime. Quicklime is what? Calcium oxide, right? Quicklime is what? Calcium oxide. That calcium oxide mixed with the water. So we are observing the reaction of calcium oxide with water. So what is reaction? What is reaction? Completely changing the characteristic properties of the substances when they combined, right? So they left a product or a new substance with unlike properties, right? So here, reaction of calcium oxide with water. So what are the required materials here? So quicklime called calcium oxide. Quicklime, right? Calcium oxide powder is required. Then we required water. We required a beaker, right? Or a test tube, right? Then here you need to check the nature of the substances. What the before, after the change, right? So we are using litmus paper to test them, right? Then here, how to process this? So in this process, what we can do, just we can take a beaker. We can take a beaker. So into the beaker, we can add water, right? Add water up to certain level, right? 50 ml, 100 ml, whatever it may be. Then what to do? Add a quicklime, right? Add quicklime into this. So you can add powder. Then what happens? It dissolves. It dissolves in the water and disappears after some time. Then what to do? What to do? Just you need to touch the beaker. Touch the beaker. If you touch the beaker, right? Before adding lime water, before adding quicklime, calcium oxide into the beaker, just you touch the water beaker. Estimate its hotness or coldness. That means heat energy you are observing by contact, that touching the beaker. So heat energy estimated. Is it giving you hot experience or cool experience? Then adding the quicklime, that is calcium oxide, into the water, right? Then again touch the beaker. Did you feel hot or cool? Notice that. Then use the litmus paper. Use the litmus paper. Use the litmus paper. Then here you are using the litmus papers, two litmus papers. What they are here? One is blue litmus paper and the other is red litmus paper. Blue changes into red in color. Red changes into blue in color. If the characteristic properties are like this, blue changes to red. That is substance nature indicated here, acid, right? If red litmus changes into blue in color, then that characteristic, that means property of the liquid changes into base, right? So here by dipping a litmus paper, you need to observe. You need to observe that suppose if you introduce red litmus paper, it changes into blue color, then we can notice here ice ice, basic in nature. If blue litmus paper introduced, it changes into red in color. What we can notice here, it is as red. So it is as acid. So here, when you dip red litmus paper into the liquid solution of calcium oxide and water, what do you notice? Red litmus paper changed into blue color. So what is your answer here? That liquid solution with basic nature or with acidic nature?
Sir, basic nature.
So basic nature, right? So what happened here after dipping these into the solution? So here, blue litmus paper remained ice blue only. Then here I noticed red litmus changed into blue in color. So by this observation, I can say that liquid hides nature basic. But before adding calcium oxide into the water hides any nature? No, it is neutral. Water nature is neutral, right? Then adding calcium oxide only changed the water nature or not? So with this observation, I am able to say that characteristic properties of the original substances changed after the reaction. Are you clear about this? Are you clear about this process? How to conduct this activity process is clear. Then here, just go for the observations, result, conclusion. What do you give conclusion here? What is your process actually? Taking the glass beaker, adding the quicklime and adding water, or taking the water, adding quicklime, anything. Quicklime is what? Calcium oxide. Then what you are doing? Just touching the beaker after adding the quicklime. So slacker lime is what? Formed after adding the calcium oxide and water. So that liquid we can call it as slacker lime. This is calcium hydroxide. This is what? Calcium hydroxide. When you touch the beaker, what you can identify here? That give you something hotness, becomes hot, beaker becomes hot. So temperature rising. Temperature rising. It is because of what? Energy released by the reaction of calcium oxide and water. Energy released, right? So this we can notice. And the nature of the substance also changed. What nature adopted by the slacker lime? Nature adopted by the slacker lime is basic. So two we are able to say here. Nature of the substance changed and heat energy released. Remember the 2 points. One is heat energy liberated and the other is nature of the substance is changed. Then we'll go for the activity number 2 here. Here activity number 2 is simply reaction of sodium sulfate with the barium chloride. Both are solids only. Then you need to prepare aqueous solutions. What is meant by aqueous solution here? Right? Aqueous solution means the solution prepared by you adding something solid into the water. Solid and water. So here water can dissolve anything, universal solvent, right? But depends on the hardness of the solid material, right? So anything will be dissolved, but it takes less time or more time. Okay, whatever it may be. So here you will get a liquid solution. Liquid solution here. So this liquid solution, not by pure water, it is by a solid present in the water. So that's why if any salt is dissolved in the water, called as respectively that aqueous solution of particular salt. Clear? Respective salt here. Salt means not eating salt. Are you clear? What is aqua solution? Aqua means water. That solution made by water. Solution means solute plus solvent. What you learned in chemistry. Solution is equal to solute plus solvent. Right? Solute means less quantity. Right? What we add into the water. Solvent means that which can dissolve something in it. It is water. Solvent is water and solute is solid or small quantity substance. Right? So solution announced means it is made up of water or any other that we need to observe. If it is by the water, we can call it as aqua solution of water. Sorry, aqua solution of that particular salt. I think it is clear to you. What is aqua solution? So you need to prepare aqua solution of salts. What here given in your activity? What is given here? One is given sodium sulfate and the other is given barium chloride. So here by adding these substances into the water, right? Into the water, you can get a liquid solution called aqueous solution of sodium sulfate, aqueous solution of barium chloride, right? So that solutions you need to prepare. After preparing that, what to do? Just here, your required materials, right? Sodium sulfate, sorry, calcium oxide written, sodium sulfate, barium chloride, sodium sulfate, barium chloride, water, beakers or test tubes, right? So this is the mistake I entered. Same. Just a minute, I will cover that. Right. Here you require sodium sulfate, Na2SO4, and barium chloride, that is PaCl2. These are the salts required. Then after that, by adding water to them, you are preparing aqueous solutions. Aqueous solutions, right? Then what to do? You need to take them into the same beaker. You need to take them into the same beaker. So here in the procedure, I'm taking 100 ml of water and adding 10 grams, 20 grams of sodium sulfate into the 100 ml water. So same amount you can take 100 ml of water, then 10 grams or 20 grams of sodium sulfate, then in another beaker 100 ml of water and 10 or 20 grams of barium chloride. Then I prepared aqueous solutions. Then what to do? Just you need to add one of the solution into other. Then what happens if we add them? Do you see any changes? Right? What your observations in this activity? That look at here, then tell me your observations. I am adding one of the solution into other. What happened? On adding, what do you see here? Can anybody respond? Can anybody respond on adding? What happened here?
Sir, a white color substance is formed.
White color substance is formed. If you left for some time, what happens? That remains size undissolved at the bottom of the beaker. So that undissolved material formed by the two liquids or one of the solid. Adding by two liquids or any solid material is added here. I added only liquids. By the liquids, I prepared a solid material which remains undissolved. It is formed and remain undissolved. So this we can call it as precipitate. It is called as precipitate. If any undissolved material formed by the two liquids in the reaction and remain solid at the bottom of the solution, that substance is called precipitate. Here the precipitate is formed its color is white color. What the substance is formed here in white color? That is asked here. That is what barium sulfate. Undissolved material is what? Barium sulfate. So here that result we can give that new substance is formed and a precipitate is formed. So this reaction you may call it as precipitative reaction. In which reaction the precipitate is formed, that reaction is called a precipitative reaction. Then we'll go for activity number 3 here. Right? That is the reaction between zinc and HCl. So what are the materials required here? Zinc, or you are able to conduct this activity by taking other metal also. So here any metal you can take. It may be zinc or maybe the magnesium granules, metal pieces, right? Then you required HCl, you required test tube or a beaker or a conical flask. Anything you can take. You need one more thing here, matchbox, right? So these are the materials required. Then here procedure, just adding zinc metal piece or magnesium metal piece into the HCl solution. Then observe what happens. Then look at the screen here. What do you notice? Added zinc metal piece. Look at carefully what you see here on the surface of zinc metal piece. Anybody? Anybody? Zinc metal piece added to the liquids HCl. What happened on adding zinc metal piece into the HCl? See, on the surface of zinc, water bubbles are formed. This is indicating you the reaction is taking place between HCl and the zinc. That is the indication. Then here, why the bubbles are formed in that? Bubbles in the liquid indicates you releasing of gas. What the gas is, we can realize that gas also, type of gas. So look at here one more. Magnesium is added to the hydrochloric acid. What happened on adding magnesium to that? It is reacting vigorously, giving you bubbles. Fast reaction is taking place, right? So on adding any metal piece to the acid, you are observing gas is releasing, right? So here in this, you are testing this gas with a burning matchstick, right? If the burning matchstick burning with blue flame, right, and giving you pop sound, it is indicating you hydrogen gas. If it is put off immediately, released gas is carbon dioxide, or it is burning with a bright white flame called oxygen. So 3 observations I given with the burning matchstick. That is hydrogen gas, carbon dioxide gas, oxygen gas. So these are the 3 activities given in your textbook. So this is today's class. In tomorrow's class, we will generalize these reactions and we will observe the types of reactions from these characteristic properties of the reactions. So thank you for joining. Give me your response immediately. Are you clear about these topics or not? Everyone? Yes, time completed. This meeting will be closed automatically. So follow what I am explaining daily. At least you read as like your newspaper to recall what we discussed in the class. Right? Thank you for joining. See you tomorrow.